All right, so this week we'll be doing quadratics. So we're gonna first start with some basic quadratic review on the answer I got on the placement test. I know a lot of you are already familiar with quadratics, so we're just gonna review quadratics real quick. We're gonna go over Vieta's formulas; they're very important, and then we're gonna do something called quadratics in disguise. We're gonna look for things that don't look like quadratics, but they actually are quadratics. Okay. So let's first start with some factoring review. Just factor these three equations. And yeah, so don't worry about chatting your answer to me because I know that might be a little hard. So yeah, and this is just review anyways, right? So I'll give you guys 5 minutes to do these. All right, guys, time. So how do we factor? When we factor, we basically ask ourselves, for the first one, what two numbers multiply to -7 but add to positive 6. So we think about our numbers and we see, oh, 7 and negative 1. So it's going to be x plus 7, x minus 1. Okay? Next one. There are many strategies you can use to solve, factor these that have a coefficient in the front. But the way I usually go about it is this method called factoring by grouping. Okay? So what I basically do is I say, what two numbers multiply to 2 times negative 3? So that's saying, what two numbers multiply to negative 6, but add to negative 5? Well, that's going to be negative 6 and 1, right? So I'm going to split this negative 5 into negative 6 plus 1. So what that's going to look like is 2x squared minus 6x plus x minus 3. Now I can group this quadratic into 2 chunks. See these 2 chunks? I'll factor each of these chunks individually. So this one, I go 2x, x minus 3. The next one is just x minus 3 plus 1 times x minus 3. So now we can see how this is the distributive property. X minus 3 is being distributed about 2x and plus 1. So if we use the reverse distributive property, this is equal to 2x plus 1, x minus 3. All right, so that's the method I like to go about it. It's easiest for me. The last one, it's a bit tricky if you don't know the rule for this. This is called, what is it called? Difference of squares. So whenever we have an equation in the form a squared minus b squared, this is equal to a plus b times a minus b. If you were to expand this out, we'll see how that works. A squared minus ab plus ab plus b squared. See how these cancel out? We'll just get a squared. Oh, actually, it's not plus b squared. It's minus b squared. A squared minus b squared. Okay, so this is the difference of squares rule. And if you don't know that rule, then it's really hard to do it. But as you can see here, a is x, b is 4, because 16 is 4 squared. So this is just x plus 4, x minus 4. Okay, so that should be reviewed for most of you. Now we got the quadratic formula. I don't think that much of you know this one, but whenever we can't factor a quadratic, so whenever we can't factor it, so if you were to try to factor these, it's not going to work. All right. So when we can't factor things, we're going to use the quadratic formula to solve for x. All right. And the quadratic formula is like this. X will equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so this is in the form ax squared plus bx plus c. Okay, and you just plug these numbers into this formula and you get your answer. And the plus minus means that the first solution, all quadratics will have 2 solutions. Okay, most of them at least. So one solution is going to be negative b plus all that. The next one is going to be negative b minus all that. Okay, so this is the quadratic formula. It's the most direct way to find the solutions to a quadratic, but it takes a lot of time. So if you have the ability to factor, then always do that. So I'll give you guys about 3 minutes. Okay, so for the first one, if we were to try to factor it, it's not going to factor out. Okay, so what we do is we use the quadratic formula. So x is going to equal to negative b. B is -1, so negative b is 1, plus or minus the square root of b squared, which -1 squared is still 1, minus 4 times 2 times 17, all over 2 times a, which is 2 times 2, which is 4. So first of all, before we evaluate this, do you notice how this square root right here is negative, right? Because obviously 4 times 2 times 17 is a lot bigger than 1, right? So 1 minus that is going to be negative. But can we ever take the square root of a negative number? No. At least in real terms, we can't. Okay? So this means that there's actually no possible solutions for x because we cannot take the square root of a negative number. So there's actually no solutions. No matter what value you plug in for x, it's not going to work for this equation. All right, so let's try the next one. Use the same thing, negative b plus or minus the square root of b squared, which is 9 minus 4 times 1 times 1, right? 4 times a times c, all over 2, which is a times 2. All right, so 9 minus 4, that's just 5. This one we can evaluate because 5 is a positive number. This is just going to be equal to, well, that's basically the answer. We can have 3 plus square root 5 over 2, or negative 3 minus square root 5 over 2. So those are the two solutions. Okay. So if you were to try to factor any of these, they're not going to work. So sometimes you just have to use the quadratic formula. All right, so that's the review. Now I'm going to do Vieta's formulas. These are really important formulas that have to do with quadratics. All right, so what they are, so let's say we have the quadratic ax squared plus bx plus c. And let's say the two solutions to this equation are x1 and x2. All right, so those are our two solutions. Vieta's formulas say that x1 plus x2 is negative b over a. All right. It also says that x1 times x2 equals c over a. And these are the Vieta's formulas for quadratics. All right. So the sum of the solutions, equals negative b over a. The product of the solutions equals c over a. Okay? So these are Vieta's formulas. Sometimes, when we have to problem solve with quadratics, you'll see later on in the problems, you're going to have to use Vieta's formulas because sometimes factoring or using the quadratic formula is not going to work. All right? And sometimes you can actually solve quadratics that you can factor without factoring them. By using Vieta's formulas, you can find the solutions to very simple quadratics. Okay? So something I often forget is this negative in front of the b minus a, the b over a, okay? You got to remember this negative. But over c over a, there's no negative, okay? So let's just test this Vieta's formulas out for, let's say, a simple quadratic. Let's do x squared plus 3x minus 4, okay? So Vieta's formulas say that the solutions x1 plus x2 are going to equal to negative b over a. So negative 3 over 1. Negative 3, okay? And it says that x1 times x2 is equal to negative 4, which is c over a. Okay, so now we just think, oh, what two numbers add to negative 3 multiply to negative 4? Well, it's going to be negative 4 and 1. And those are the solutions. Because if we were to factor it, so we know that the solutions are negative 4 and 1. If we were to factor it out, what do we get? We get x plus 4, x minus 1. So this means that x plus 4 equals 0, or x minus 1 equals 0. So x is going to equal to negative 4 or 1. So this just shows that Vieta's formulas do work. Okay, but there are lots of different applications for these formulas that you're not going to be able to solve some problems without them. All right, let's do these problems now. Oh no, I already gave you the solutions to the first one. So maybe just skip the first one. When you get your answers, you can chat them to me because these are a lot better to do. So let's make this one a minus 18. Oh, when you get your answer, you can chat it to me. But I'll give you guys 3 more minutes. 2 more minutes, actually. All right. So let's go into the second one. A and B are solutions to x squared plus 5x minus 132409871239487. What is A plus B? Well, if we were to try to factor this, I think that would be almost impossible. If we were to try to use the quadratic formula, that would be even more impossible. So, in this case, what do? We got to use Vieta's formulas, because Vieta's formulas say that A plus B, the sum is going to equal to negative B over A times B is going to equal to C over A. So don't get these confused. A and B are the solutions. These are the coefficients, okay? So we want to find A plus B, so that's just negative B over A, negative 5 over 1. That's just negative 5. Okay, so we don't even need to care about whatever this is to find the sum of the roots. Okay? Next one, very similar. All you want to find is AB. We don't care about this, what that is, right? So what's that going to be? AB is going to equal to C over A, which means negative 18 over 3, negative 6. And that's it. Okay? So Vieta's formulas, we can find what the product of the roots are, even though we don't know what exactly the roots are. Okay, we don't know exactly what numbers A and B are, but we know what A times B is. Okay, so that's kind of like the cool thing about Vietas. So let's go on to these two problem-solving problems. They're like more, these are from the Mathcounts competition. And let me add in an extra one. So first work on these, I'll add in an extra one. So those three problems, I'll give you guys 10 minutes for these because they're actually kind of tricky. Warren, do you have a question?
No.
Actually, guys, you can skip the first one because I think it's a little out of range. Because I don't think it's going to be that difficult for the math counts. Just work on the second two. All right, so how about I go over the first one, and that might give you guys a better idea of how to do the second one. Okay, so first one, we want to find 1 over a plus 1 over b. But Vieta's formulas, they don't tell us anything about what this is, right? They only tell us what is a plus b, what is a times b. Those are the only two things we can find from Vieta's formula. All right. So the trick here is, how do we manipulate whatever this is so that we can represent it in terms of these two things, right? So one thing we can do is, let's just say we want to directly add these two into one fraction. Okay, so how do we add fractions? We want to get the greatest common, the least common multiple among these two numbers, right, in the denominator. So we're gonna have to multiply this by b on the top and bottom, this on the top and bottom by a. We're gonna get b over ab plus a over ab. Same denominator now, so let's just add them together, a plus b over ab. Oh look, we have manipulated this equation, whatever this is, turned it in terms of what we do know from Vieta's formulas. A plus b we know is negative b over a, which is going to be negative 9. A times b is c over a, which is just 33. And that's the answer. Okay, so the tricks of these problems is manipulate the equation so that you can represent it in terms of things that you do know. Okay, so with that hint, give the last problem a try. All right, let me go ahead and explain the last one. So we're going to take a very similar approach for this one. We do not know what a minus 5 times b minus 5 is. But let's just expand it out. So if we were to expand this, a times b is going to be ab minus 5a minus 5b plus 25. Let's factor out the 5 right here. So we got negative 5a plus b. Oh, look what we have here. We know what AB is from Vieta's. We also know what A plus B is. So we'll just plug these in and we'll get our answer. All right. So A times B, we know that's this over this. So it's negative 3 minus 5 times A plus B. A plus B is negative this over this. 15 over 4 plus 25. Okay. So now we're adding fractions now. So we got to get this common denominator. So we're going to multiply 4 over 4, 4 over 4. So it's going to be negative 12 minus 75 plus 100 all over 4. It's going to equal to 13 over 4. And that's the answer. Okay, any questions? Cool. Now we're going to go over some quadratics in disguise. Some equations you're going to look at and you're going to say, oh, those are not quadratics. But sometimes they actually are. So let's look at this one. X to the 4th minus 13x squared plus 36. Obviously, this is not a quadratic, right? Because it's got x to the 4th power here. But we can turn this into a quadratic by noticing how x squared is x to the 4th. All right, so if we were to say some y equals x squared, then x to the 4th is y squared. So if we represent y as x squared in this equation, we'll get a quadratic in terms of y. So this is going to be y squared minus 13y plus 36. Once we get y, then we can plug it back in here and solve for x. Okay, so what is y? Well, we can just factor it. Y minus 4, y minus 9. Okay, so y minus 4 equals 0, y minus 9 equals 0. But actually, let's factor this, okay, completely. So we got y minus 4, y minus 9. So at this point, we can put x squared back in here. So y is equal to x squared. Ooh. This is the difference of squares. This is the difference of squares. So this turns into x plus 4, x minus 4. This turns into, oh, not x minus 4, x plus 2. X plus 3, x minus 3. And there you have it. That is this, but we factored it by representing y as x squared. So we would turn this into a quadratic. Okay, so this is a very good problem-solving technique. So sometimes when you look at something, it doesn't look like a quadratic, but you can turn it into one. Let's go over these two problems here. Once you get your answer, you can chat it to me, and I'll let you know if you're right or not. Okay. So the first one, if we look at this closely, this is obviously not a quadratic at first glance, right? So how do we make this into a quadratic? Well, note how 4 to the x is just 2 to the x squared, right? Because this is the same as 2 squared to the x, because we can just switch it around, which is just 4 to the x, okay? So if we set 2 to the x as equal to some y, and we plug this in, we have a quadratic in terms of y. So it's just 2y squared minus 17y equals negative 8. Move the negative 8 to the other side, so we get a nice little quadratic. Oh god, wrong pen. Plus 8 equals 0. So now let's just factor it, right? If you're to factor it, I'm going to use my strategy again. What numbers multiply to 2 times 8, which is 16, but add to negative 17? Well, negative 16 and negative 1. So 2y squared minus 16y minus y plus 8. Okay, we basically split up that negative 17y into negative 16y minus y. I've got two chunks here. You can factor each of these individually. 2y, y minus 8, minus 1, y minus 8. 2y minus 1, y minus 8. So y is going to equal to 1/2 or 8. But that's not the answer, because we want to find x. Because the first equation wasn't x, we got to get this into x again. So y is equal to 2 to the x power. 2 to the x can equal to these two things. But we know that 1/2 is 2 to the negative 1, so x can equal to negative 1. 8 is 2 to the third power, so x can equal to 3. So those are the two solutions for x, negative 1 or 3. Okay, next one is very similar. At first glance, this is a little bit deceiving, right? We don't really know what that is. Well, if you note how the square root of x squared is x. So if you say y is square root x, it's a quadratic in terms of y. So it's just 11y equals y squared plus 30. Move this one to the other side. Now we just factor it. Y minus 5, y minus 6. So y can equal to 5 or 6. So that means square root x is equal to 5 or 6. We can just check our answers. We can square both sides if we want. X equals 25 or 36. Okay, so that's it. Okay, so stop sharing. That's it for this week. See you guys next time. Bye.
Thank you. Bye.
Bye.